Welcome to office hours. Um, I think a bunch of you have been at different ones of these or have seen recordings. Um, but this is really just kind of part of this ongoing initiative to build a community around people that are thinking about game data. Um, Magy and Erik and I are very actively working towards developing a proposal that will be part of what NSF calls research infrastructure. And to get this going, we've actually been granted an award to form that proposal and to build this community and figure out what the parameters of it really are. So we're really excited about trying to figure out what a national level infrastructure that uses games to do education, psychology, research, what that would look like and how that would unlock researchers. So along the way, we're like building best practices and we're building infrastructure pilots as we go. And I think it's worth noting that we've got some stuff online that you can go over to. So the Open Game Data website is probably the big one. There's also a Slack. I'll drop the invite into this in a minute. That's a great place to ask questions and talk about projects and coordinate, meetups and conferences and that kind of thing. And then the point of the office hours really is to provide like a space for working through raw ideas that are like not complete yet. So this session, for example, has kind of been a long time coming. I think like how Jaclyn and I have been working together on and off, like talking about projects and proposals and stuff. And Doug and I are proposing something that kind of in a similar space. So this ends up being like one of those times to actually like share where we're actually at, what we're learning, where we're getting stuck. And if we're successful, it'll be a bit of presentation to get us all going, but then it'll lead into a conversation that's generative. So the main kind of goals of this, I would just say, is like the thing we want to come away from today with is really helping the presenter understand their own project, their own goals, and hopefully like whoever's presenting is like coming away with something fresh and feeling a little supported and got some new ideas. They are recorded and I'll post this up to YouTube. There's a collection of them up there already that are actually good fun to watch. The only other thing I'll mention is that, everybody's sharing work that isn't perfect. It's like it's raw. So like this is really a time to just be respectful and I don't know, just be considerate of that that position that folks are in. And yeah, hopefully we'll come away and learn something from this. Okay, so that's a little intro. And Jaclyn, I'll just let you introduce yourself and what you're getting into today.
Sure. So I'm Jaclyn Ocumpaugh. I'm the Associate Director for the Penn Center for Learning Analytics at the University of Pennsylvania. And I've been working in the field for a little over a decade, primarily in affect dynamics research. Our group builds a lot of detectors of affective states that takes a different approach than a lot of other groups. We do not use sensors typically. We have instead gone out and done very careful observations and then linked those observations very exactly to student log files and made predictions about what kids were doing when they were bored versus what they did when they were confused. For example, in 2020, John Rowe at NC State and I told the NSF we would do this with Crystal Island, and we would also run the sensors. And that was January. And in July, they gave us the green light to go ahead and try to collect that data, which was awesome in the middle of the pandemic. So we had a little bit of a stalled out period where we decided to build some self-reporting tools that were inserted in the game. And we now have two sets of detectors. But one of the things that we've had issues with in terms of detectors of lots of constructs is we can make a lot of inferences about what kids are doing from those log file behaviors, but that doesn't necessarily know what the next step is, right? Even if we have the survey results and they're reporting it in the moment, we don't necessarily know what the next step is. Okay, you're bored, stop. Like it's not a there's not a direct fix on some of these. So several years ago, shortly before the pandemic, we started investigating these issues with an app called CureF. So I'm going to try to figure out how to share my slides without exposing you all to entirely too much information from the rest of my desktop today. I remember how to do this in Zoom. All right, and then, haha. All right. So title today is Data-Driven Classroom Interviews. So whatever detector or even just actions that we're seeing in the log file, we can trigger using an app called Quick Red Fox. And that allows us to collect contextualized data on student interest and motivation or other constructs at scale, right? So again, I said this is newish technology. The QRF app stands for Quick Red Fox now. I think initially it was intended to stand for Qualitative Research Fast, but it took about 5 years for Ryan Baker to remember that. So we've just been calling it Quick Red Fox. It is being tested out now. This is our second project with it in Chad Lane's Whimsy environment. So it's the what if hypothetical environments in Minecraft, where they have taken different and created different worlds in Minecraft. And so one world is Earth and one world is Earth without a moon. And there's a very accurate Mars modeling system for another world. There are exoplanets, so I got to learn what those are. Some of the kids came in already knowing exoplanet axial tilts. So we've got a range of, astronomy and Minecraft experience coming into the classroom. And what we're hoping to do is to better understand how we can develop and support situational interest and get students to develop individual interest, which is the more intrinsic interest in STEM. Right? So just, a little bit about the Quick Red Fox, right? Previous methods that have tried to get at this have included things like post-event interviews. And this is something that's worth trying. I don't know how many of you guys have kids. If my kid had a bad afternoon, the entire day at school was terrible. So particularly with affective experiences where there's not like a concrete yes, no answer on how things were, did something occur or not? If we wait till later, then we're capturing a bunch of reflection and not the in the moment experience. Other efforts have tried to get at the in the moment experience, and those include talk alouds. So that's where we ask the kid to just keep talking and explaining what they're thinking the entire time that they do something. They don't like this. I don't like having to do it. It's a lot of work. It's fairly distracting for a very long time. And usually you have to have somebody sitting next to the kid going, no, keep talking, keep talking. No, for real, keep talking. Which, probably also doesn't make the experience more enjoyable. So what we're trying to do is really targeted in situ interviews so that we can get that information about why learners engage in certain kinds of behaviors or don't. It's really challenging to capture these without having that immediate trigger coming out of those log files. And then, we've spent a fair amount of time even just today trying to figure out, okay, how long before that trigger expires even, how long is it going to take me to get across the classroom and figure out which kid I need to talk to? By the time I do that, will that event be out of their mind? Will they still be willing to talk about it? Will they have gone on to, griefing on another kid and we'll have to talk about that? Or, is it a fairly safe thing to say, hey, if we've got it in 2 minutes, it's okay. We initially tested this not in the Whimsy environment, but in Betty's Brain, which is a system developed by Gagnon at Vanderbilt. So in that case, we had affect triggers built already for the system. We'd gone in the first year and done the prompt observations and had those running in real time. And we triggered both on the affective states and then also on certain kinds of behavior. So if the child had just gotten a pop-up message that said, you should go read about, I'm blanking on the topics, but they were looking at climate change in the one instance. So you should go read about what is happening with the water system, right? And instead they went and looked at forestry information. Then we had a trigger. We had enough triggers on that first effort that it was a little difficult to try to get at those targeted issues. So we ended up using a little more generic interview strategies, which is good because I think we found out a lot about the kids and it was very comfortable. Whereas if we come up and said, hey, why aren't you reading that thing we told you to do? It probably would have been perceived of as a little bit creepy. So we're also working to sort of balance that out as we develop our interview strategies. Okay. So here's a picture of the current version of the app. This right now has a random check-in instead of an actual targeted event because we've been doing a lot of testing and I haven't switched up pictures. But what you can see here, right, is that we're connected to this system. I'm using the username Ryan today. That's whoever is doing the observations. And then the trigger details here, if it was, for example, somebody placed X number of blocks or, you know, torches or whatever in Minecraft, then it would be that. Or they're running, or they've been away from the group for more than 3 minutes, or they've been next to one person for 5 minutes. That would be where the random check-in is. It's going to give us a random trigger ID in case we need to take notes in the moment. Not usually necessary, but this is going to be part of the metadata that goes with the system. It's also collecting a lot of other metadata, including, you know, timestamps and other information. And then the username is the name of the child's account that we're going to go target. And with Whimsy, it's fantastic because they use all animal names for the kids. So with the exception of the child that they gave the tardigrade account to, it's a very friendly way to approach the kids and still have it de-identified on the transcripts later, because I can walk up and say, hi, butterfly, how's your day going? And most of them take that really, really well. Tardigrade was less receptive. But it's, you know, they've been kind of getting into it. We can record the feedback, or well, we have recorded feedback, but we can record the audio interview with the child using the big red record button here. If we have other notes to take, we can make them here. And we have 2 new boxes that are not yet into the slides because they came in last week. But they are an override box. So if we want to go talk to a different account, person associated with a different account, we can put that username in there. And if there is an additional child being recorded on the audio, then we can actually go ahead and put that in the metadata as we're going so that we're not frantically trying to figure this out, because children's voices are ridiculously difficult to deal with in terms of audio. The higher pitch is a big thing. The other thing I'll tell you is we go in with big fancy newscaster microphones to do this. And so we make a big deal at the beginning of, look how fancy we look. We're going to push this right in your face. If you really want us to go, we'll go away. But if you think we're chasing you, it's just because it's going to record about this far out, right? And it does a pretty good job of muting a lot of other noise, but sometimes we do still get that data. And sometimes it's really useful data because sometimes there's some crosstalk that is happening between the interviewee and another kid, and we're actually getting a lot of engaged participation captured in that experience. So anyhow, we can, like I said, approach the kids relatively instantaneously within a minute or two. If we didn't like the trigger, if things weren't going well in the classroom, if a fist fight erupted, we could hit skip. We can move on. A couple of times, actually, in the Betty's Brain Project, we had one little kid who just had no self-regulation, emotional regulation skills at all. He mostly sat there with his head down for 2 weeks, so we did not bother that child, even with full permissions from his parents and an assent form signed. You know, we're going to give that child some space. For the current project, so the Betty's Brain Project ended just as the pandemic was starting. And we've gotten the Whimsy one up in the last year. We just submitted our first annual report on that grant. And so we've done a pilot study in Maine at an observatory where we had a lot of students who were clearly self-selecting to be there and come in with a lot of knowledge. And then we've had 2 camps with various levels of lower knowledge and interest in either Minecraft or astronomy. So we've got a pretty good range already, and we're going out again next week to an after-school program in California. So we have the learning environment. We connect it to the QRF server. Basically, they install what they call a listening server so that when the triggers happen, that, it kind of takes note. And then we have a prioritization list that I'll show you in a minute that decides which one to push out. So the server is going to receive that list of behaviors, like I said, prioritize it, and then decide which one is the top priority based on the criteria that we've given it before we got into the field. And then it sends it to our little app on the phone. And Camille has done this with me. A couple other people have done this with me. We can then, try to get to that kid as quickly as possible without causing disruptions of any other sort, as much as possible, right? When it's done, right, we hit next, we stop the interview and we hit next, and it'll send us the next trigger. If classroom conditions are good, we continue working as long as we can. If classroom conditions have changed, actually with the Whimsy project, aside from anything that might have been happening that was distressful for the child, there's a lot of downtime in between online activities because they are trying to do some, hands-on activities in some of these camps so that they give the kids, for example, a thermometer even just to go measure, okay, what happens if you're in the sunshine on the asphalt versus under the shade tree over here. And then they've given them a couple of other tools that are maybe a little more exotic, including one that's going to measure gravity. It's not going to change a whole lot, but they actually get to hold one in their hand and play with it a little bit. And then when they go into the game, then they have those same kinds of tools, and they are encouraged both to use those tools and to make observations. Okay. I think I covered this already. With Betty's brain, we had 2 different kinds of triggers. We had the affective experiences, and then we had what we called incohesive behaviors. So we suggested you should do something, or you got information from a quiz. Did you actually follow up on the things that you scored poorly on, or did you go look for something easy to work on because the quiz grade made you mad, which we documented in the interviews fairly effectively, actually. With Betty's brain, again, we started by asking, hey, how are you doing? Is it okay if I talk to you? What's your strategy? And a lot of them were actually a little frustrated with that system, and particularly in one of the first implementations where we went out, they had a pedagogical agent named Mr. Davis. The way Betty's brain works is the kids are building a big concept map where they're putting causal arrows between, okay, this causes this in climate change, and then, eventually the glaciers melt and we die. Or, it's hopefully we find a solution. But they have to figure out, what causes what, causes what, causes what. And they'll take a little quiz, and if the causal map is well, then their character Betty has passed the quiz. And if their causal map is not complete, or if there's a missing link in there somewhere, they'll be given, quiz grades that reflect that. They try to give those in fairly short bursts so that, like a quiz has 3 or 4 questions. And even though it's a giant causal map, then the kids are supposed to go find the section of the map that needs to be edited. Sometimes the kids know how to do this, sometimes they don't. They also, like I said, had this pedagogical agent named Mr. Davis. And in the first implementation, they had tried to make Mr. Davis a little sarcastic. And so he would show up ostensibly to help kids. And if they asked him a question, sometimes he would give them an answer. And sometimes he would say, "Humph," and walk off. And other times he would say, "Wow, that's hard. I'm glad I don't have to teach her," and walk off. And my 12-year-old is very sarcastic, but he does not deal well when I am sarcastic towards him. And some of these kids were in that same space in terms of development and willingness to, you know, be on the other end of the roast. So we found that out fairly quickly in interviews. We actually made those changes because it was so distressful to some of the kids very quickly before we went back out for the next implementation. So it was a nice example of how quickly we could make a change when we saw that something had gone sideways. Apparently just changing from "humph" to "hmm" is a huge improvement in how Mr. Davis interacts with young people. So for now, right, we're working on our interview strategies. And I said, we've been out several times, and I'm just going to overwhelm you probably with what we've got. Open-ended interviews, you know, are important because we want the kids to tell us what's salient to them, right? But, you know, a lot of research on interviews says that that's what you're going to get, right? What's happening to that kid in the moment and what they are able to actually have metacognition of in the moment. And that's only really if they like you, right? So, you know, you have to work at it a little bit, but a lot of kids, particularly when they're angry at the system, are very glad to tell you why it's broken. So, you know, that first round with Mr. Davis, we got a whole lot of information, and then we were like, oh yeah, no, that's terrible. And they liked us, and they were willing to tell us all kinds of things after that. When we have worked on the Whimsy project, a lot of them are really excited to be playing Minecraft and can very effectively go off task. And so they are less excited sometimes to see us. And we've been sort of teasing out, okay, can we find pain points where they might be a little more irritated with the game or their friend, where it might be easier to get them to, you know, take on those first couple interviews so we can have those bonding experiences. But generally, you know, our goal with QRF is we want child-friendly language. I've told Camille, your goal is big sister, not big brother. True for other gendered interviewers as well. But we want somebody who's going to keep them from beating the crap out of the friend next to them, right? But they're not going to bust them for passing notes, right? That's the level of authority that we want in there, right? Some guardrails so they feel safe, but not, we're here to tell you how to learn, and we're going to bust you if you're not doing what you're supposed to do. If you're off task, you're off task. So, you know, that's data for me. It doesn't hurt me at all. And, you know, generally just as much verbal and nonverbal feedback that we're listening, and oh, that's so cool, and oh, could you tell me more about that, and can you explain it to me, and make them an authority so that they feel comfortable telling us things. Like I said, some things are going to come out very, very naturally. But, you know, if they're embarrassed by something, it might not, right? If the metacognition isn't high enough, it might not. You know, one thing that emerged with Betty's brain is we had a fair number of kids with science anxiety that were in the classroom. I will say, as an anxious person myself, I got that diagnosis at 30 and went, what? That's not normal, right? It just feels normal when you have anxiety. Several other friends have gotten diagnoses since, and they were really surprised. And I was like, oh, I'd have told you. I thought you knew. So it seems to be common for adults even, so expecting kids to know that they're anxious and nervous and being able to articulate that, even though we could sort of see it happening in the moment, required some adjustments to the interview strategies while we were working on that project. So like I would start to ask things like, hey, what do you do when you get frustrated? Even to the kids that weren't telling me I'm really upset in the moment. And then I watched a couple of kids who got feedback, and, you know, as I said, the quizzes would have 3 questions, so you could find out one piece of the map, and they were so upset by the grade that they deleted all 40 concepts. And so I started asking questions about other kinds of strategies that might tell us about anxiety versus interest and other self-regulation. Right? So as I said, we want to take a non-authoritative approach. We want those nonverbal signals to be, conducive to them continuing to talk to us. There's some trial and error on figuring out when to repeat what they've just said to you. Oh, really? You like that? Versus, paraphrasing something larger, or going on to the next question. We're working on avoiding leading questions and, sort of the abstract versus the concrete questions. Sometimes you need those concrete questions to get them going to the more abstract concepts that we're actually interested in, like, how much do you like science? So, going in and saying, hey, what do you usually read, in between other questions about their efforts in the system, can give us some ideas about, do they pick up nonfiction or fiction? What genre do they like? What are they going to do for fun? What other kinds of games do they like to play? They're all super child-friendly questions, and they can kind of let us weave back and forth between that space, right? We're also working on just trying to make sure that we're identifying student assets, and that's just because we're trying to make sure that we are helping developers work on identifying what the current knowledge schema are among the kids so that we can then connect it to that. And again, some kids are more willing to give you home life information than others, for a lot of reasons. But it's, a work in progress, I guess, on how we go about that, right? So, what's your strategy better than, hey, did you click on the horse? Right? Which sort of tells them what they should be doing. What have you tried, as opposed to, did you do this other thing yet? Have you tried reading X yet? Versus, why don't you like doing the reading? Which is, starting to then get really accusatory. We've got examples of abstract versus concrete questions. So, what do you like about science is kind of the big question that we're looking for, but, a lot of people will blank if you say stuff like that. Give me a fun fact about you is terrifying for the people with anxiety. Like, I don't know, I don't do things. I mean, maybe I do, but if you ask me a point blank question like that, it's going nowhere. So, if you can say, hey, what's been the best or worst thing about science class in the last week or this year? Then they can usually come up with one thing, and then you can kind of bridge to, what made that better. If you ask a kid, what do you mean when you say that you find this is boring, you're not going to get a super helpful response. They're going to take it very literally. So, what would make this less boring or less painful or more interesting? And like I said, just some examples on prioritizing student assets, right? So what are they bringing into the classroom? What are they really good at? What do they like to do? The last trip out, somebody was particularly bent on messing with me, and he was adorable, but like, he insisted that his father was LeBron James, and his cousin was Drake. But it gave me an opening to start asking him about basketball, because that was apparently the thing that he really, really cares about in life. And then we tried to see if we could get any connection between basketball and science, and I got nowhere with it. So we're going to have to go back to the curriculum developers and see if there's a way to make that bridge, because I can't do it in the moment in the interviews. But maybe there's a way to do this in a child-friendly way that gives them some activities outside of the system when they're doing those other things. Maybe gravity and basketball could be a new topic for the outside events that are happening. Maybe there could be a basketball course going into Whimsy. We'll have to see. So like I said, Whimsy is this what if hypothetical implementations in Minecraft, and it is actually a suite of different worlds. We've been using, I think, 8 of them, but I think there's close to 20 that have been designed. And what the kids do is they start by exploring, and particularly the first couple of worlds, they are given the science tools. They usually don't use them very much, And so day 2, the team comes back in and starts giving out posters for the people who made the best observations that reflected science tool usage. So if you had somebody that said, hey, the temperature changed from here to there, or who took on a more sophisticated tool, then they give prizes out to just kind of remind the kids that it's there and we're not just running around playing Minecraft. Oh, well, now we have illustrations. So here's 3 different pictures of things that are happening on the Whimsy system and the Whimsy server. And you'll see that there are scientists and, different kinds of environmental differences that they could be looking at, in addition to things like changes in gravity and distance from the sun and all those fun things. And we proposed that we would look at this in terms of Heidi and Ranger's 4 phases of interest development. And although she has 4 phases, this, simple version is, we try to trigger the interest, maybe with Minecraft, and get people to actually engage with the science. And that's sort of the situational interest. And then as kids acquire knowledge, and it's actually really key that you have knowledge, then you get to intrinsic interest. And I think this has been something that I think I knew before we started doing these interviews, but it's definitely something that we can see in the interviews, right? The intrinsic interest surveys will say things like, or ask things like, hey, do you read science books for fun? Or do you keep a science blog or whatnot? And most of these kids are 12, right? So you might think, no, they do not. But in fact, some of them do. And their behaviors and interactions are quite different. And their knowledge level is very, very different. We literally had kids coming in knowing the axial tilts of the exoplanets that were being modeled. So, this is the bigger version of that one. We've actually sort of broken these down and worked on, okay, what is it? We had learner characteristics and feedback needs from Heidi and Ranger's model, and how might that correspond? I don't want to totally overwhelm you guys with this. I had some of this blocked off, but I can't seem to adjust it in the moment. No, okay. So some fairly generic questions will actually get you to this, and then like I said, we can modulate along as we need to. Right. Some of the challenges that we have been in developing triggers. So it's very unstructured data, and we've spent a fair amount of time analyzing it before we even tried to do the first couple of pilot studies to figure out, what are the places that we actually want to talk to kids. So if they're using the science tools appropriately, that would be a good example. You'll notice that in some groups of kids, the mean for, measuring oxygen is pretty low. Same for gravity or the radius of the Earth or whichever planet they're on. Radiation level seems to be one that they have some knowledge of, but maybe don't use as often. But then when we get down to altitude or tectonic activity, then, we see almost no usage of those tools in some cases. And so if those are happening at all, we'd want to prioritize talking to the kid with the tectonic, as long as we're trying to prioritize the high knowledge, high interest students, right? If we're trying to go talk to the ones that have lower knowledge, then we might alternate between, are you goofing off and are you, making an effort with something that is concrete enough for you to understand. So, like I said, the learners are making observations. There seems to be spikes in when they do. Some of this is related to whether or not they're allowed to build that day, because the first 3 days are very exploratory and they shut down the building options in Whimsy. And then the last 2 days, they're supposed to be building a base camp for an outpost on Mars. And so tool usage drops pretty substantially usually as they go through that process. Right. We've looked at the degree to which the codes that we're gathering from this are related to interest. So we've got a publication going out that's looked at are the code or the observations that they're making actually making any observations at all, or are they talking to their friends? Um, so are there social interactions? Are they talking about sussy among us? Or are there more help-seeking activities? And, you know, can you explain to me how to do this in Minecraft? Game literacy kinds of questions. Or, you know, strings of random letters also show up. And I said, we've done lots of analyses to look at these. We've been trying to map out points of interest in the system. Our XY coordinates are pretty reliable. The Z coordinates have been a little more difficult to interpret, just because the elevation changes are unpredictable. But we've got some crack grad students on this, and they're doing some good work. So we're making a lot of progress on that. We can currently tag when a learner is near a bunch of areas of interest in several of these worlds. I think we're still working to increase the number and our understanding of what those might mean. And then we've also started to look at things like how much of the world has the learner explored, right? So did they stay really close to their base, or are they out griefing other kids? Or checking on other kids' bases to get ideas or applause. You know, are they racing back and forth on the bridge because that's the fun thing, or have they actually checked to see, you know, what kinds of tasks they could be doing that would be more scientific? And then, as I said, we have a feature prioritization list. These are pretty tiny for you guys. The first one says the user is in Manoa, which is one of the worlds. And if I believe, if I remember correctly, Manoa is actually a model of Earth, but after the moon has gone away, so that the tides have changed, and gravitational effects are different. So that would be, you know, priority one would be, have they gone without doing any observations for 25 minutes? Okay. Let's go find out why they haven't bothered to do anything. And then, you know, sort of lower time limits we might make lower in the priority list so we don't miss the things that are harder to get to. If somebody has used a tool near a point of interest where it would make sense to use a tool, then we can write the code accordingly. And in the last few months, we've also been working on trying to get a lot of details on which blocks they're using, because we've seen they're given instructions to use steel and water to protect against radiation. And some of them are doing that as intended, and some of them really want a pretty base. And so we're trying to figure out what those building and rebuilding patterns are. Okay, so I've given you guys the overview. We start off with Whimsy. We go through its database and pull whatever behaviors we're going to trigger on in through the QRF server, and we send it out to the app. And as I said, you know, much of what we're doing right now, we have a lot of work in progress because we are still waiting for transcripts on the interviews that we've got done. And that's been a big bottleneck. We have tried running through automatic transcriptions, and with little kids' voices in a noisy classroom, even with the good mic, it's not a great system. We have also decided over the years that it is mean to make master students, particularly when you're maybe in departments where not everybody is a native English speaker, to make master students do these transcripts. So we actually have somebody who is a professional court transcriptionist that we have been using to make sure that we're getting the accuracy that we need. We really want to understand that interest development here. And then, as I said, with Betty's brain, we were looking at self-regulation more generally. I've talked a little bit about the anxiety that we found that was not part of our proposal, but we were able to capture initially through the interviews, and then we did add a science anxiety motivational scale to the surveys that we gave to the students. But one of the things that we found that I think is maybe one of the coolest results that we've had from affect detection research in our lab at least, is that there was a change in frustration for students with science anxiety. So if we looked at the whole 5 days of implementation, we did not see a difference. And if we looked at each single day of those 5 days, we did not see a difference. But if we compared the first half of each day to the second half of each day, the students with high anxiety saw spikes in frustration that were significantly different from the students that didn't have science anxiety. And if you gave them a break and let them come back the next day, then it was back to normal. Which I think gives us some ideas on a fairly simple intervention, which would maybe just
Give people a break.
yeah, like, like tell them to stand up and stretch, right? So that's exciting. I don't know if that's been implemented since the world shut down, and we didn't get another grant to go back and work with Gagnon. The other kind of cool thing that we've seen, and this is one that I like to brag about a little bit, because we had a couple of reviewers on a couple of grants say, oh, well, you're going to interrupt their learning. But we're doing, usually with Betty's Brain, 3 to 5 minute interviews. They're a little longer with Whimsy because we're waiting for them to want to talk to us. So they're a little more sparse and a little longer. But we're 5 to 8 minute interviews with the Betty's Brain data. If there was confusion happening and they talked to us, they usually had an opportunity to talk through that. And we actually saw improved learning for kids that were interviewed during a point of confusion. So we're not completely unobtrusive, but we're not damaging the learning
Yeah. Well,
activities.
there's all the literature on self-reflection. It suggests, like if they're confused, let them talk, help them talk it out. You're going to learn. So
yeah, so
that might be a good thing to point out in the grant applications.
Yeah, we've
as a counter to that. Cite Chi and to say this is good and this mirrors what we've seen.
Yeah.
Had that one off at the pass because I can imagine that's an easy critique on an NSF panel. Yeah, I see that.
It was
happening.
Something I was concerned about when Ryan was like, hey, I have this new toy. And I was like, because what am I asking? Do they want to talk to me? Yeah, sometimes they do. Not always, but sometimes. But yeah, like we got a lot of research out of the Betty's Brain project. And like I said, I think the coolest ones were related to frustration and anxiety, but the fact that we were able to target that also, I think, suggests a potential obvious intervention and just maybe signaling a teacher to go talk to the kid right now, particularly if it's a kid that we think might be of lower self-efficacy or lower interest or whatever else as we work to develop those models. Yeah, so I think there's a lot of future stuff that we can do with this. The 2 grants that I'm working on now, aside from the one that David and I are gonna finally get this year. So David and I have tried twice now, 3 times to get the NSF 3 times to get the NSF to let us do this, to go ask for culturally responsive information from the kids during pain points and to look to see how the culturally responsive designs that he's already implemented are being received. This week I'm trying to put in another grant with Crystal Island, and so we have, I think I told you guys at the start, we built 2 sets of detectors. So we built one based on the prompt observations once we finally got back in the classroom, and then we built a second set that were based on the self-reporting tool that we've created out of desperation from the COVID events. And we have a lot that we'd like to do with that self-reporting tool, which is a separate issue. But one of the things that we found was that when we compared the detector output, so not the initial training data, but the labels that were produced by the detectors, that they didn't always align, but that, you know, some were picking up on learning, whereas the corresponding affect was not associated with learning when it was measured with the other tool. And then in one case, we had an instance where confusion was associated, I think confusion was associated with learning if it was detected by the self-reported detector when the prompt detector was predicting engaged concentration, but it was only happening for low self-efficacy students. So we're looking into, okay, what does it mean when these detectors disagree? Because it turns out when you ask children how they're feeling, about a third of the time they tell you that they're bored. And some of those, like I said, some of those are probably true. But some of those, there's probably some other emotions going on, and maybe trying to tease out, you know, why is it that some students are robustly demonstrating confusion, and others are better able to sort of power through it, and adding like some frustration tolerance surveys to that effort, I think is where we're headed with that. And then the next grant that we've got going in with this is with the Carnegie Learning Mathia system. So it's a cognitive tutor that's been pretty carefully modeled in terms of what steps kids need to learn before they move on to the next concept. But they have Bayesian knowledge tracing running to predict when the kid has mastered a concept. And they have also been looking at student carelessness, which is they've got defined as they've gotten a wrong answer after that mastery label has been applied. I think in some cases it could be true carelessness in they don't care, right? And in some cases it could be carelessness as in I don't know what just happened, right? And in some cases it could be cognitive load or imperfect mastery or the fire alarm just went off. And if we can kind of tease out the differences between I'm having trouble focusing and I'm having trouble with motivation, that could really improve our ability to apply interventions for those detectors as well. So this is most of my team, some of my team from the Whimsy project. And I'm also supposed to advertise that we have a journal every time I give a talk now. So we have a journal called Computer-Based Learning in Context that is a free open access journal that we are encouraging, particularly people from non-Western places, but we actually would like to have the Western places join as well because it raises our Scopus index and makes it acceptable for those other parts of the world to participate on this platform. But I am open to questions. Hopefully I didn't take too long and use too much time, but thank you guys.
I have a question.
Mhm.
Yeah, thank you very much. That was amazing.
Yeah, this is awesome. This is so awesome work. It's like, yeah. I'll stop there. Get out of Doug's way.
Where do you think the future is in terms of what you'll be able to do with the detectors you create in environments like this is part one, and what kinds of infrastructure do you need in the host environment to really achieve that end? So I like the fact that you're not using probes and things and sticking electrodes in kids. So but then the question is where could this go, and what would you need in the host environment to be able to do it?
Right. Well, I mean, I really came from, not the learning sciences. I came in as an acoustic phonetician, so working with sensors. There's a big advantage to doing the observational data collection. It's easier to get into the classrooms to begin with to do it, but also anytime the kid turns or gets up or whatever, that system just generally breaks, and it's hard for it to make a prediction. We are more often wrong with the affect detectors that we've built. But I do think that we're on the cusp of sort of figuring out what the real inflection points are. So the research on affect dynamics has sort of said, the kid's going to start engaged. They're going to get confused when they hit an obstacle. Maybe they'll resolve it. And if not, they get frustrated. And if they don't resolve it, they get bored. And then God knows. But we know that kids are getting bored when they're understimulated too, right? And so a lot of the things that were supposed to happen in that model aren't occurring very frequently. And if we get out and do a little more contextualized information and figure out, okay, is this real damaging frustration, or is it, geez, pleasurable frustration? And in some cases, I think we'd actually have a delight detector in Crystal Island now, and we're seeing that the high self-efficacy kids are hitting more frustration, but they're bouncing between frustration and delight.
And what kind of data in Crystal Island that Crystal Island is giving you is letting you decide that and act on that? And what do you wish Crystal Island had that it doesn't have to do a better job of it?
Yeah, so we've built the detectors this spring, because it took us till 2023 to do any data collection on that grant. So we just now have them this spring. I think, I would like them to give me more money and let me go play with the QRF app. But I think that if we're seeing the kid bounce back and forth between boredom and frustration, it's a much bigger problem than if we're seeing them bounce back and forth between the frustration and the delight detectors. And we probably are in a place where we could start to do things with that now. I don't think it would take very much instrumentation for the detectors to work in real time. I don't have the programming background to
say about that. Yeah, I was just wondering, like, if the game only let you know, has the kid turned the game on or off, for instance, at a very crude level of back-end functionality in Crystal Island to support, that would obviously be really limiting. What other kinds of, but now obviously they have a lot more than that. What is it they have that's really allows you to do the ones that you have? And what do you wish they had that would let you do more?
Right. Well, I mean, if the way we've constructed the detector is they make predictions every 20 seconds. And they make it based on previous data so that we can go in and in real time make the prediction. I think what we'd be looking for this grant would be to look at, okay, so we know that they're frustrated and not in the fun way. Do we need to give them more guidance on how frustrating situations are normal in science? Will they buy that? Will they care? Or do we need to give them sort of knowledge interventions so that we can get them to a place where they care, that interest level starts to go up. And those are, I think, the kinds of questions that we're still desperately trying to work out in the next 48 hours.
Great. Well, thank you. I'll let somebody else ask questions. I have lots of questions. I could ask you questions for an hour, maybe 3. But that's really cool stuff. Thank you.
Thanks for the presentation, Jaclyn. I would like to know more about how the detectors are working. Is there some papers or something I can go to check out?
So we've built them for a bunch of systems now. We wrote a manual in 2015 and we cite it. So if you do some citation chasing, because I bluntly cannot keep up with Ryan Baker's publication efforts. So I'm not even sure how many systems. I know that it's more than a dozen. I think we read a write-up, and it was Alexis Andres was the lead author, and I think it was 2022 where we did a review of prompt-based detectors. The COVID years are a little fuzzy, so I may not have the date right, but that would be one.
Did you check an assumption? This kind of builds on Evan's question. It seems to me that you've got some detectors that are just straight algorithms. They're like the user was within X amount of pixels of this location, right? Those are kind of like those just stand on their own. And then there's others that seem to be much more complicated and machine learning driven, like the ones that are
The affect detectors for
detectors.
machine learning.
Yeah. So, okay, so that's good, just to kind of verify that. On the ones that are affect driven, one of the questions I've got is how many observations are needed? Like, I don't even know how to scope this in my mind of like hours, number of observations, number of kids, number of researchers, because obviously it's expensive to have you in the room, or it sounds like Camille does this work as well, but that's expensive. So eventually you want to say, okay, we train detectors and we're happy with their performance. For at least the Bromp and emotional kind of affect stuff, do you have any guiding ways to talk about that?
So Rebecca Stein did an economic cost analysis on Bromp detectors, and I think there were some estimates in that, but there's not really a good power analysis for this. And to be super blunt, like we've not done a great job. Like we don't, when we Bromp certify somebody, we say, hey, you're now certified to train somebody else. Just tell us who you've trained and we keep a list. And we're looking for a cap of 0.6, which is a little lower than we usually see in a lot of psych literature on inter-rater reliability. But we also assume that these are very holistic experiences, and that, Camille and I might look at the same kid and she would say confused and I would say frustrated, and neither one of us would really be wrong, right? That there might be some element of truth to both of them, and being over practiced might not be in our benefit. When we started building this, I think there was a lot of hope that they would generalize really well. We don't have any student level demographic data where we've looked at that, but we have looked at school level demographics, and we did see differences between urban, suburban, and rural schools. So we do try to make an effort in some cases as appropriate, something like assessments where there's 50,000 students using it, then we try to go to more than one school. Something like Crystal Island, they're mostly using it for science experiments run by NC State related to learning. Then, we're not going to pretend that we're going to get that level of data. And we kind of do what we have to do. So Ryan's got much higher knowledge on the machine learning requirements on stuff like this. His estimations are that our most important thing is that we're cross-validating, and that we are at least making an effort to try to get diverse students when we can. So, for example, one of the data collections we did with Crystal Island was with an all-male school. I would not train the detectors there and then apply it somewhere else. But the other concern that's happening right now in terms of machine learning and these algorithms and stuff for reporting is that there are very good reasons not to put demographics into a model, even if it'll get you a better prediction. And I will say, like, even as somebody, who came in with linguistics, who knows just how different the vocal tracts of grown women and grown men are, not of little kids, believe it or not, they figure out other ways to do that. But for grown people, you actually have to have a separate set of algorithms to measure vowels for boys and for girls, right? So even knowing that, if you went in and said, hey, we're going to use one algorithm for the boys and one algorithm for the girls, as a parent, I would have concerns, if we were using different algorithms for, African American versus white. Even if we knew that there were good cultural differences happening, I would have concerns. So, our algorithms are performing about half as well as me standing in the classroom trying to match somebody else. And their inter-rater ability is about half. But we've been able to apply those to very large data sets. And as long as we're, either using enough data for the application, or if we're triggering interventions, if they're fail-soft interventions. So like, I'm not ejecting a kid from the class if they're off task, but I might nudge the teacher to go talk to them. Not going to hurt the kid. At least if I don't say, hey, the kid is a loser, don't talk to him, right? If I just say, hey, so-and-so might need a little extra attention, it's probably fine. And that's kind of the goal, right? With any of these interventions, is just to make sure that if we do something, that it's something that would generally benefit everybody. But that we're trying to tone it down so that we're not constantly poking at the kid and telling him to self-reflect, or, whatever it is.
This is good. We're at time and a tiny bit over, but I would just love to see this method get used across a lot of games. And I'm also very curious about sharing data sets of the raw training data and letting other data scientists play with it. So like, what are all the ways you could code these detectors given this game log? It feels like this is just a really, it's cool that you've all pioneered like basically a whole new way of doing research. It's really cool. It's like a whole method of its own. Yeah, it's very, very cool. Okay, let's wrap it up for today. Yeah, obviously we can follow up in the Slack and do questions and stuff, and I look forward to seeing you all in a few weeks. I think I'll post the schedule again, but I know that one of our next ones that's scheduled is Evan and Kevin are going to be co-presenting on some work that they did. Do you want to give a little blurb for that real quick?
So we're working at Noggin on a cross-content learning impact rating. So being able to measure, because we had such a large sample of kids playing the Noggin platform, being able to measure content that overlapped in terms of what constructs it was targeting, and then being able to kind of get a sense of like student progress or player progress in different pieces of content, and kind of be able to compare which pieces of content are performing better or worse from like a learning perspective. So we're going to the kind of the weeds of building those models and some of the challenges we faced. And then of course, Noggin got axed late last year. So it's not like continued work, but it's still, intellectual ideas that are very interesting, and work that is being done at other places like ABC Mouse and PBS Kids and stuff like that.
That's great. I'm really looking forward to that. This kind of generalizable of approaches here. And then another topic I know that's coming up that I'll be facilitating is I would love to have our community come around and talk about our kind of 1.0 general logging spec. We've published a bunch of papers over the summer, and I'd love to have just a conversation around putting our first like most basic event schema together. I think we're all really close, and I've got a feeling with a little bit of alignment, we'd have something that everybody feels like, yeah, I'm on board with adopting that spec. So I know that's one of the other topics that'll come up here in the short term. Reach out to me on Slack if you've got anything you want to share and just get some feedback on. And I look forward to seeing you all in 2 weeks. So
thank you.
Great
Have a good
afternoon,
day,
everybody.
everybody. Thank you, Jaclyn.
Yeah, thanks
Great
again.
to hear your work.
Thank you.
Thank you.
I appreciate the invite.